For this video segment, you guys, talk about ionic compounds. There's another video that talks about covalent compounds as well as polar and nonpolar covalent compounds. This is the other type. This is where the electrons are not shared. And so in order to get that full outer energy level, metals will give up their electrons. So that means no sharing of the electron. And so if we take a look at this, here sodium has this one electron. So for sodium, it can either gain 7 more electrons, because notice it only has one electron out there, one. It has one valence electron, so in order to become full, it can gain 7 more, which is really difficult to do. Or it can just give one up to chlorine. Chlorine has 7 valence electrons. So chlorine, same thing. Chlorine could try to lose 7 electrons, but it's really tough to lose 7. Or chlorine could just gain 1. And so we look right here, chlorine now has 1, 2, 3, 4, 5, 6, 7, 8. Chlorine now has a full outer energy level, but notice there's a pink one there because it got that pink one from sodium. Now sodium, if I look, 1, 2, 3, 4, 5, 6, 7, 8. By giving up that electron, sodium now has 7 electrons in its outer energy level, so sodium is now considered stable as well. So with covalent bonds, we saw that the electrons had to be shared in order to be full. In ionic bonds, they're given up. And in ionic bonds, we generally see a metal and a nonmetal. And I'll say generally, there are a few exceptions out there, but you and I, we won't deal with any of those exceptions. Sodium is a metal. Chlorine. So this idea of ionic bonds, a metal bonding with a nonmetal, the metal generally will give up its electron to the nonmetal. So by giving up an electron, sodium becomes a positively charged cation. We don't pronounce it cation or cation, we pronounce it cation. So sodium is the positive cation, and by gaining an electron, we don't say anion, we say an ion. Chlorine becomes the negatively charged anion. And again, we see that opposites attract, positives attract negatives. So in ionic bonds, there is a cation and an anion. Cations are positive, anions are negative. And so that's how we generally look at ionic bonds. It's a bonding of a cation and an anion. Ionic compounds, it's generally a metal and a nonmetal. We saw that. And they have a neutral charge. We saw those oxidation numbers generally always add up to 0. They have a crystalline structure and some general properties. They're typically solids at room temperature. They have high melting and boiling points. They tend to be good conductors of electricity, and there's a lot of use in industry. You can see by the picture included on this slide, ionic bonds are used widely in the world around us.